Hello, this is Mr. Larson, and you're watching the first of 4 videos on the chemistry of life. Today's lesson will include information on the atomic structure and the periodic table. So let's start in. Alright, so here's a picture of an atom, and there are 3 what are called subatomic particles that are found in atoms, and that's what we're going to discuss in a minute. Those 3 are protons, which are right here in the red. They have a positive charge. You also have green colored ones here called neutrons. And then the last one are negative charged electrons. And those are yellow and those are whizzing around the outside. So let's start talking about each of those. So, as I just said, the first of the 3 subatomic particles are called protons. These are the red ones right here. They have a positive charge, and they have a mass of what's called an AMU, an atomic mass unit. This is something that chemists use to define how much an object weighs, particularly a subatomic particle, like a proton or a neutron or an electron. So, protons have a mass of 1 AMU. And they're also found in the nucleus. And so in the middle right here of the atom, this region right here with the protons and the neutrons, that is called the nucleus. So now the next one we'll talk about are neutrons. So neutrons are the green ones here in the nucleus in the middle. They are neutral, they have no charge, hence the name, right? Neutral. Neutron, okay, and they also have a mass of 1 AMU, same as a proton, and they're also found in the nucleus. So, right, this region here, protons and neutrons, is the nucleus. Last one to go, the electrons. And the last of the 3 subatomic particles are electrons, and these are the yellow ones right here. They have a negative charge. They essentially, for biological purposes, have a mass of 0 AMU. We're going to say that they don't have any mass. They actually do have mass. I don't remember how much, but it's negligible, means not a whole lot. And they are not found in the nucleus. They actually will move or orbit around the nucleus. So they go whizzing round and round and round the nucleus. And this is where interactions between atoms to make molecules happens. It all happens with the electrons. So now what we're going to talk about is information you can get from the periodic table of elements and how to calculate electrons and protons and neutrons and how many are in each of those elements. So let's go there. Alright, so here's a website that has the periodic table of elements in it, and I will give you a hard copy of this in class tomorrow. But some information that I want you to get from the periodic table, it looks kind of confusing. It's kind of all the elements are arranged in rows and columns. And so in biology, there are 6 elements that I want you to know information about. And I like to refer to them as SPONGE for short. SPONGE. So they are sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. And on the periodic table, they can be found here. So there's sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. So I'm left-handed, so I like to go backwards and everything, so I start at the bottom and work my way up through the periodic table. So what does this show you? What is the periodic table? Why is it important? What information can you get from it? And what they've done is they've blown up this right here. They took carbon, number 6, right? I'm going to say carbon is important, so carbon's right there. And they blew up that box, made it really big. And it has some information on it, some numbers and stuff. And so here's what it can tell you. The first in the upper left-hand corner is a 6, and each element has its own what's called atomic number. So in this case, carbon has an atomic number of 6, and that will tell you the number of protons, and it also tells you the number of electrons. So remember back earlier, I said protons were positive, so in this case carbon has a positive 6 protons, and it also has 6 electrons, and electrons are negatively charged, so it has minus 6 electrons. And overall, plus 6 minus 6 cancels out to be 0, and so each element is going to have its own, it's going to have a neutral charge, it's going to have an overall charge of 0. So that first number, the atomic number, tells you the number of protons and the number of electrons. Then as you move down, you have a chemical symbol, so it's either 1 or 2 letters. In this case, carbon is represented by the letter C. Then the chemical name, so carbon. And the last number down here, that's 12, that tells you, basically it's the total mass of one atom. And so, or the atomic weight. So if you were to take one atom of carbon, it would have an atomic weight of 12 AMUs. And so the atomic weight is measured by the number of protons plus the number of neutrons. So in class tomorrow, what you're also going to have to do is tell me how many protons, how many electrons, and how many neutrons are in a bunch of different atoms. And so how do you calculate the number of neutrons? Well, if you know that the atomic weight is 12 for carbon, and you know that it has 6 protons, you can subtract 6 from the atomic weight, and then that will give you the number of neutrons. So that's how you calculate atomic weight. Another cool thing that I'll talk about in the next video is basically for biology, we're just going to look at the first 3 rows of the periodic table. It gets a little more confusing when you get down below those 3 rows, but hey, that's next year when you take chemistry. So for right now, just if you're just count the number of elements in each row. So the first row has hydrogen here on the left, and it has helium way over here on the right. So the first row has 2 elements in it. The second row, if you counted them all out, would be 8. And the same with the third row. The third row would have 8. And that's going to become important when we talk about valence electrons and bonding. But that's the next video. So, hope you enjoyed this video, and I'll look forward to seeing you on the next one.